This example here, this ponytail workspace pulls the sculpted guides from another workspace called the ponytail guide. So where the guides were sculpted, it ingests that guide data. Groom workspace also enables quick switch between different presets of colors, material parameters. There's an attribute tab that gives clean, controllable output data management. There's a stats tab that provides point and curve count for debugging purpose. And additionally, a finalized groom can be saved on disk on the fly to reduce useless cooking time. So whenever you open your scene again, you don't have to recook the groom on and on. Alright, so let's start our advanced tooling tour with the element styling tools. The first set of grooming tools we provide is dedicated to creating complex hairstyles, such as braids, buns, cornrows within minutes. The bun styling tool ingests scattered points on the skin and converts them into unique variations of donuts or knots. It can be scattered points using a scatter node, or it can be points coming from a curve you draw on the surface. In this example here, we are feeding the bun tool with a few sculpted and mirrored curves, and every point on the sculpted curve is converted into a bun that can then be transformed directly on the skin, and it's easy to adjust the height, the base radius, and the overall shape of all buns at once. The shape type can be switched between nodes and donuts, along with scattering modes for high or low density generation. Many controls offer extensive flexibility in shaping the final look very easily. The tool also supports adding several variants of buns to the scattered points, assigning variants randomly or manually. So for example, here a second variant can be changed to a completely different bun type with its own scattering, its own radius, shape parameters, regardless of the first variant. It's very easy and intuitive to use. Braids are another complex element system to build while grooming. This braid tool converts any curve input into a realistic braid with lots of easy controls and detanglement. In this example here, the braid tool is connected to a guide groom node and allowing these mirrored sculpted curves to automatically turn into a detailed braid structure made of tubes. Controls for profile size, width, height, thickness along the curves are easily accessible and intuitive to use. The braid subdivision quality and the frequency of the knots can be adjusted on the fly, and there's a lot of directability on the making of the braids with additional settings like twisting and rolling, and all these parameters can be randomized to create a more organic look. So, plugged into a tube-filled node, it instantly converts to curves to be used as strands or guides, up to you. And in this case, the tubes are turned into a high-density strand system meant to be rendered. Features like detangling remain active, and modifiers such as twisting per clump can be applied. Just like with the bun tool, new clump variants can be added too. So here, for example, the blue clump is swapped out for a different variant with independent control over its density, its thickness, and styling options. You got a lot of granular opportunities here to style your braids on the fly. In order to help complex grooms to blend better within a complete hairstyle, we are also adding a tool called the cornrow styling tool. In this example here, a guide groom node is used to sculpt new mirrored curves on the head, and these curves are then fed into both the cornrow and the braid tools, with the output merged together. When a curve is drawn, both tools generate cornrows and braids at the same time, following the same path. The cornrow tool includes options for adjusting the push and the bending of it, with lots of controls. Density and scattering distance can be easily adjusted using simple sliders. So merged into a single workspace, it doesn't take more than sculpting a single curve to quickly build a detailed braille layout that sits naturally on the surface of the head, just drawing one curve. So now onto our modulation tools. This second set of tools we introduce focuses on strands modulation. We want to remove as much graph network complexity as possible, as well as reducing the amount of VEX or Python coding knowledge that is necessary for the most trivial or repetitive grooming tasks. So we are adding plug-and-play modulation nodes for more accessibility, but we're also introducing a new clump node called the Metahuman Groom multi-clump that allows for multiple variants of clumping within the same system, similarly to the bun and the braid variants that we've seen earlier, as well as the ability to twist. As you can see in the bottom middle, the clump twists on itself. It powers our subclumping method that I will present to you a bit later. Two examples of quality of life additional nodes that we provide are the straggle node and the spread node. The first provides a straightforward way to apply noise modulation to curves by simply leveraging Houdini's native noise, but optimized and bundled up to be used on curves. Users can control the noise along the curves, switch between different noise types, adjust parameters like the frequency, the amplitude, and apply the randomness. Very easy to use. The Grooms spread node increases the volume and shape of the curves by simply leveraging Houdini's bend tool without additional setup. Its behavior may be familiar to the Maya XGen users already, as it allows for spreading curves on two different directions, called a round and lift spread. Again, we wish to simplify as much as possible very redundant grooming actions that could otherwise require additional graph setup or even trivial VEX coding, but which can end up being time-consuming and additional efforts for no real good reason. Another good example of our simplification toolkit is the Metahuman Groom width node. It allows quick curve thickness modulation at any point in the graph by simply dropping and connecting the node, again removing the need of point wrangles or VEX coding for such an essential and simple action. It allows different modulation modes such as simple gain, overriding, randomization, and it comes with a lot of procedural masking options as well as effortless usage of masks and textures. Controlling curve thickness is essential during grooming, both for look development and optimization. It even becomes critical when we are creating new LODs, for example. What is also critical is the ability to paint masks and textures for grooming. We are adding another set of tools focusing on this topic. In this example here, this modified version of the texture mask painting node provided by SideFX allows users to plug in curves as well as the first input. As you can see, the painted texture is automatically transferred to the curves and can be composited with other existing masks using the Combine tab. This enables quick, on-the-fly remapping of a new curve attribute, preserving the texture resolution accuracy, but allowing curve modulation. In this example here, creating a quick tips level mask based on textures using a single node with no additional setup or VEX coding. Another node called the attribute UV jitter is designed to quickly add jitter or noise to existing masks. It's a fast solution to add more organic irregularity to painted masks on the fly. In this example, mask A gets applied in noisy edges, when mask B drives where the jitter is being applied, enabling targeted modulation. The setup is, for example, useful for creating an irregular hairline on the forehead, for example, while maintaining your smoothly painted texture on the nape area. So you can target where the jitter is applied. Now let's jump into a big topic for grooming. It's clumping. As introduced earlier, at the beginning of this session, clumping can make a significant difference between a low quality groom and a polished one. Our goal here is to remove from users the struggle of building complex clumping graphs with a quick and robust solution. As shown here, the master clump has been broken down into several colorful primary clumps. Each primary clump can twist independently and be modulated by adjusting the tightness, the curl, the straggle, adding flyaways, noises, length breakups. Primary clumps can then be divided into secondary clumps, which also support independent twisting and the application of any modifiers introduced earlier while maintaining the integrity of the primary layer. The same is true for tertiary clumps, an even smaller layer of subclumping made for tiny details and flyaways. This robust pre-built setup enables the entire structure to retain its integrity from guide clumping down to tertiary clumping, and it's all available by using a single node. That node is the Groom Builder. It's our jack of all trades tools for grooming. It uses point attributes and textures for density mask to generate new curves, as you would use hair generating from side effects. But it can also take in existing curves as a source, like this high density ponytail here, for example. From there, Groom Builder let users layering modulation and styling. In this example here, there's already some clumping that is set up down to tertiary clumping, as shown earlier. And we've added flyaway clumps, adjusted all layer tightness, and introduced length variations. It's also possible to add after clumping styling and modulation on strands, adding global flyaways here, a bit of around spread to boost the volume, some frills to break up the parallel lines, add length variation to break up the tips. Overall, the Groom Builder makes it easy to go from a basic, as shown here, to an interpolated groom to a more advanced and stylized result in just a few clicks using a single node in your graph. So we've covered a big portion already, and we will now look at other types of nodes that we're adding on top of the artistic grooming nodes. It's our utility-centric nodes. Our first example here is the Groom Curve node. So it allows filtering of the input curves using various parameters such as probability, length, and more. It can take an input mask to modulate curling based on its values. So a mask going from 1 to 0, 1 will be preserved, 0 will be called out, but the values in between will be used as probability values for smooth transitions. And you can also use it to filter attributes to isolate a unique centroid curve out of a single clump, for example, as we will see very soon. All these filters can be activated all together for a combined effect. Clump attributes. So as you can see here, each color here is a single unique clump ID, and you can isolate one centroid curve out of it. So it's very useful for optimizing grooms, but also to create new set of guides that are like literally output from your original groom. We're also introducing the Viewport Live node. It's a convenient solution to add a grooming camera. It's useful for digital grooming and matching a background reference for a human actor, for example, so you can lock the camera and eyeball it around your reference. And thanks to the exposed options, background color and different viewport quality presets are easily accessible in just a click to make sure that your groom looks as best as possible in the conditions you want. It also enables switching between 3 different light rigs with intensity, color, and rotation controls. 2 of these light rigs are locked to the same direction as the camera to ensure that you have consistent lit if you want to do like viewport turntables or things like that to quickly iterate. Also part of the utility nodes is a set of groom validation and debugging solutions, such as the Groom Doctor, that takes all grooming elements such as strands, skin, and guides and runs a complete diagnostic on them that helps making sure that the groom is ready to be sent to Unreal Engine and create a clean groom asset. So it will be able to repair automatically if you want some of the errors, but also it can create a grouping based on some things that might be problematic that you might want to fix on your own. So it will also make them obvious for you, it will report them. The Groom transfer RBF will make sure to transfer both strands and guides from the source to a target entanglement head in a robust way. I insist on the fact that it's doing the transfer on both elements, strands and guides, in a consistent way, because both are needed for a good Groom asset in Unreal Engine. Making it easy to populate on different MetaHuman heads, for example, or iterate less painfully with new head shapes coming from the modeling team with production updates, for example. Finally, we are adding a dedicated tool called the MetaHuman Groom Export. It takes strands, guides, and skin as an input, and is able to pull all the data from a single Groom workspace that was used for grooming, so in a plug-and-play fashion too. So if you've been grooming in a Groom workspace, outputting the strands, the skin, and the guides data, you simply need to tell the exporter to pull the data from that single workspace, and it will bring all the correct info by itself. You don't have to pick each element one by one. It provides useful export options like adding color, attribute management, and the ability to bake a quick, on-the-fly ambient occlusion on the strands as an ambient occlusion attribute. That is just made right before export, which is very useful. The result is an Alembic file that is easy and ready to import into Unreal Engine. So now that we've exported an Alembic file using Groom Export, it contains all the necessary strand and guide data correctly formatted for Unreal Engine. Once imported, that data becomes a Groom asset ready for shading, LODs, and full MetaHuman integration. You can see the result here. On the left, the Groom inside Houdini, and on the right, the same Groom imported into MetaHuman Creator in Unreal Engine. Let's take a look at how to do that next. As we move into Unreal Engine, this plugin takes the Alembic file and converts it into a Groom asset, which acts as a container for everything related to Groom. So I'm going to take my time here to follow the video so you can see every step one by one. As you can see on the screen, that includes setting up the hair material assignment, adjusting the strands data, interpolation settings, haircut generation, mesh representation, and configuring physics parameters like stiffness, and lastly, level of details. So after importing, the next step is to create a binding asset, which links the Groom to a specific skeletal mesh. In this case, the MetaHuman Groom head. Once the Groom is bound, we make it a MetaHuman compatible by configuring it to a wardrobe item. As you can see, we set the binding, and the pipeline is set to default Groom. This integrates it to the MetaHuman system and allowing it to be assigned just like any other hair asset. So now we are planning the new MetaHuman character creator, and once it loads, we can assign the Groom directly in the MetaHuman Creator interface by navigating to hair and clothing selection and dragging in the new wardrobe item. So now your hair is part of the hair library. So now that we've walked through the full pipeline, from authoring in Houdini to integration in Unreal Engine, let's take a short moment to talk about optimization. This ponytail is a good example of optimized grooming, reduced density, simplified curve, thicker strands where it counts. For instance, the core of the ponytail can be heavily reduced, while detail is preserved along the edges and the silhouette, where the visual fidelity matters most, right? Tools like Measurement Groom Curve, Measurement Groom Width, and the resample from SideFX let artists simplify and balance grooms right in Houdini before exporting. Level of details help manage performance by reducing complexity as the camera moves away. Techniques like culling and width thickening help maintaining the groom's silhouette with fewer resources. The hair card generator converts strand-based groom into a textured hair card for distant melodies and resource-constrained platforms. These cards retain the flow, the volume, and silhouette of the original groom while reducing render overhead. All right, let's talk about the most important info here, where to get the tools. You can download them from the Measurement for Houdini listing on Fab. There's also a starter kit that includes both the Houdini project and the UE project with a sample measurement package, groom asset, binding, and wardrobe item. It's a useful reference for working across both environments. That you've seen what the Measurement Groom tools can do and where to find them, let's take a look at what's coming next. We are working on new tools to support more flexibility for grooming workflows. And one of those is the Measurement Character Assembler. It's a system that lets you transfer measurement data from Unreal to Houdini, making it easier to groom directly on custom measurement heads. We're also introducing a new set of parametric grooming tools built to help users generate complete hairstyles quickly and from scratch. These tools rely on pre-generated guide data, letting artists produce clean base grooms in minutes. They're ideal for rapid iterations, especially during early developments. Facial hair measurement is a key focus moving forward. We're expanding the toolkit with tools to support high-quality facial hair creation, including features for eyebrows and eyelashes. And that wraps up the roadmap. For more hands-on info, visit the Measurement documentation on the Measurement website, download the tools and the starter kit from Fab, and please also reach out online to me or to the Measurement team with any question you might have. The team is looking forward to seeing what you create, and I hope today's session gave you a clear look at what's possible with the Measurement Groom tools. Let's take some time for Q&A, and thank you for joining me today.
Hello.
Hi.
Great presentation, by the way.
Sorry?
Great presentation, by the way.
Thank you.
Thank you. My name is Murian. I want to ask about the MetaHuman tools.
Yes.
And Houdini. What about the dynamics here? Can you export it through the tools as well?
The dynamics?
Yeah, the dynamics.
So when you build a groom asset, actually that's why I insisted on the guides part. Is that the guides you export will be the actual thing that will build the physics asset from your groom, right? So basically, if you have like let's say 5 guides, so you have 5 guides falling from your head. These 5 guides will be these chains that will build the actual capsule system to drive the physics and collisions, etc. So that's why it's quite important for you to make sure that you vet the guide system based on what your hair needs to be doing when it's animating around. So building the groom asset with guides on it will automatically build everything you need for physics. You'll probably have to change the capsule size, etc. But
do we still need to bake
to bake what?
To cache the groom movement, the dynamics groom movement, and then export it into Unreal, or it just export through the tools?
Don't take it for granted, but I do believe that if you export the groom without guides data, what happens is that the groom asset will probably recompute a new set of guides to generate the physics asset. So if you don't have guides, if you didn't bake them out, then very probably the groom asset will sort out something, but it won't be vetted by you, so it probably won't be like perfectly working for your case. But it should probably work. I can't remember exactly what's the current status. So, thank you very much. Thank you.
Hello.
Hi.
I just wanted to ask if the tools are dependent on the metahuman topology, and if so, are there any plans on using these tools for animals and fur and stuff like that?
Yes. So there's a very limited amount of the tools that we provide. There's probably like I think I've released like 37 tools on the package that you will download now. There's just a few of them that are really dependent on the metahuman topology. All the rest is literally just curve manipulation tools, so you're free to use them for whatever curve-based system you want to do. These are grooming tools generally before being only metahuman-centric. So these are, Houdini curve manipulation things, right?
Awesome.
Yeah.
Thank you.
Welcome.
Hello?
Hi.
So you mean this tool is kind of like generic tool for like hair, fur? So any groom or fur artist can learn this and use in any kind of like
So
character?
can you speak a bit louder, sorry?
So the fur and groom artists,
Yes?
they can just use this for any kind of like production,
Yeah.
like any kind of character,
Yes.
right? Just like a tool, not just for meta-human.
No, it's a complete free set of tools, and so the only thing you need to know is that it's part of the MetaHuman EULA. So anything you can do with MetaHumans, you can do with this tool. So because MetaHumans are EULA that lets you use MetaHumans for whatever you want, pretty much, then you're free to use these tools for any artist to whatever they want to.
Yeah.
So same usage.
One other question is that.
Sorry?
One other question.
Yes.
So now Blender has a like good tool for grooming also.
Yep.
Is there any like future plan to like do a tool for grooming in Blender?
For grooming
for meta-human?
For grooming in MetaHuman, you mean in engine?
In Blender.
Oh, in Blender?
Yeah.
No, I mean not for now, because like Houdini is probably the most powerful tool that can let us build our own tools dedicated to MetaHuman, which is why we chose MetaHuman in the first place, Houdini in the first place, sorry. Blender is good, and you're free to use Blender if you want to make grooming. It's just that we've made internally the choice to build our tools for production on Houdini, so that's why we are releasing these tools now, which were made for production internal. We're not planning on making tools for Blender. I mean, if there's a lot of requests for it, maybe. But the extension of what we are doing right now is probably more aiming towards Unreal Engine directly, more than trying to cover all the CCs from now on. Are there any other questions? Yes, right here.
Hi.
Hi.
When you export the LOD and the hair parts, do they export the textures as well? From make it into a UV pack?
Do you mean the skin textures or the hair?
The hair.
So on the exporter, you have a color tab where you can pick whatever attribute, because when you on curves, you don't have UVs, right? You only have the U information, which is the length of the curve. But basically, it's point attributes, right? So if you have a color attribute on your curves, on your points, then you're free to export that as part of your export. So whenever you go into Unreal Engine, you will be able to read that color information. So you can definitely paint in Houdini, export that color information as part of the room, and use it into Engine. Same goes for the ambient occlusion. It will, if you choose to create an ambient occlusion path, it will create a new point attribute on the curves called groom_AO, and that is the attribute you want to use whenever you go into your material in an engine. You want to call that attribute as a point attribute that can be read as like an additional pass for coloring or shading. Like that. Yeah.
Thank you.
You're welcome. Another question.
Thank you before for your presentation. And from the all the complex results on earlier, when we export the asset, do we get all the LODs included?
All the what, sorry?
LODs.
All the LODs? No. So this exporter right now only exports the actual version, like what you feel is the best version of your group, right? Because this is a strand-based system. We are using Houdini because it's able to build very accurately like strands-based stuff, right? So we are only providing for exporting strand-based groom expected to be the best quality you can achieve, right? Because it's literally strands. If you want to create LODs, you have systems in engine that will be automatically be calling out the density of the grooms, increasing the thickness. So let's say it will halve the density but double the width to compensate, right? So you have LOD solutions like that. Another thing that is very important to know is that Unreal Engine comes with experimental tool called the hair cards generator, and it will automatically convert your curve-based groom that you've exported from Houdini into a cards system. It is very experimental yet, so it's not working for every case scenarios, especially very long hair or very complex hairstyles, but it's being worked on by engineers at Epic, so it will improve in the future. But you already got this option, so if you want to be very optimized, you probably want to go with cards. You can generate cards from the original group. If you try with the haircut solver generator, it probably won't be always working well for you. In that case, then you're on your own kind of originally, like people have to vet their own cards. But hopefully in the future we will provide more and more solutions to ease the process, because making cards is kind of a hard thing. But in Houdini, you can have a lot of solutions, right? If you know how to do your thing in Houdini, you can pretty much sort out maybe solutions on your own, how to build from your original groove a new system of cards, following your groove, etc. You're on your you have to expand your Houdini knowledge with it, but it's definitely doable.
Thank you so much.
You're welcome. Do we have other questions? I guess we're good. Then thank you very much. Thanks a lot for coming. Thank you.
Thank you so